All right, let's dive straight into this explainer. If you've ever felt like, a serial plant killer, despite your absolute best intentions, well, you're in exactly the right place. Today, we're officially putting on our detective hats and changing the way we look at plant health forever.
So, why is my plant dying? Literally every single gardener, from the absolute beginner to the seasoned expert, has stared down a withering plant and asked this exact question. And what's our first instinct? We usually rush to blame a bug, or maybe we assume it's some sort of vicious fungal infection. We want a villain we can actually see and, well, spray. But as we'll discover from our source material today, the real culprit is almost always something entirely different.
We're going to treat your ailing plant like a literal crime scene. Here's our investigation plan. First, the plant crime scene. 2. Biotic versus abiotic suspects. 3. The environmental mastermind. 4. The disease triangle. And finally, diagnosing symptoms and clues. Let's get to it.
Section 1. The plant crime scene.
Okay, to make a proper diagnosis, you absolutely have to follow these steps in order. Step 1. You've got to know what the plant is actually supposed to look like. Sounds completely obvious, right? But it is crucial. Some plants just naturally have variegated foliage, meaning their leaves are intentionally striped or maybe yellow-green. If you don't know that's normal for your specific plant, you might diagnose a perfectly healthy plant with some terrible virus. Once you know the baseline, step 2 is strictly checking for environmental causes like temperature, drought, or soil conditions. You always do this before you ever move on to step 3, which is looking for pests.
Moving on to Section 2, biotic versus abiotic suspects. So our suspects fall into two really broad lineups: living biotic accomplices and non-living abiotic stressors. On the biotic side, we have the living organisms, your fungi, bacteria, viruses, and insects that directly feed on the plant. But then on the abiotic side, we have the non-living environmental factors. We're talking drought, sudden freezes, massive heat waves, high winds, poor soil drainage, or even chemical injury from herbicides. These abiotic environmental factors, they don't spread from plant to plant, but they cause immense system-wide stress. And this quote right here, this brilliantly illustrates a massive paradigm shift in gardening. Bugs and fungi are usually just the opportunistic accomplices. They aren't the real mastermind. Our sources emphasize that insects and pathogens rarely attack healthy plant tissue. Let that sink in for a second. Often, a plant has already been severely stressed by an environmental abiotic factor long before the diseases even move in. But because the bugs are just so easy to spot, they get wrongly blamed for the full shebang.
Which brings us right to Section 3, the environmental mastermind.
You can spot this environmental mastermind by looking at the crime scene's actual physical footprint. Environmental damage leaves super specific clues. It's usually really uniform across an area, or it might follow straight mechanical lines. Think of a broken irrigation row or a path where fertilizer was way over-applied. Plus, if you see the exact same symptoms affecting completely different plant families at the exact same time, say your lettuce, your tomatoes, and your flowers are all wilting simultaneously, you are almost certainly dealing with an environmental problem, not some contagious biological disease.
By comparing these distribution patterns, we can basically rule out infectious diseases in a snap. For instance, if the damage is uniform, sudden, and affects all the plants in a low-lying wet area, boom, environmental drainage issue. Biological infections, on the other hand, are sneaky and progressive. They start at an initial point and spread outwards in a scattered pattern. And they're usually highly host-specific. A fungus that attacks your roses is incredibly unlikely to just jump over and start attacking your lawn grass.
All right, Section 4, the disease triangle.
This is a foundational model. It absolutely proves that a pathogen all by itself actually can't cause a disease. It needs a perfect storm. If any one single side of this triangle is missing, and especially that favorable environment piece, the disease literally cannot take hold and destroy the plant. You need a susceptible host plant, you need the actual pathogen, but crucially, you need a favorable environment. The spores of a deadly fungus can be sitting right on the leaves of a susceptible tomato plant, but if the environment isn't favorable, say the weather is totally dry and the fungus desperately needs high humidity to germinate, well, the disease triangle is broken. The infection never happens. This is exactly why managing your plant's environment is your absolute best defense. Let's bring it all together in Section 5, diagnosing symptoms and clues. Take a really close look at this bare, dying canopy. A rookie detective might just assume some terrible fungus swept through.
But the true mastermind, it was actually the extreme environmental stress of a poor site and root damage from nearby construction. That environmental trauma essentially starved the tree. It totally weakened its natural defenses, and only then did it invite opportunistic rotting fungi in to finish the job. If you just tried to spray this tree for fungus, you'd be completely ignoring the actual cause of the crime.
Now, check this out. We're looking at scorch, that yellowing, browning, and basically death of tissue from the margin inward on this witch hazel leaf. This is a textbook sign of abiotic drought stress. The environment is pulling water from the leaves way faster than the roots can ever replace it. Though it's easily mistaken for a fungal infection, this is purely an environmental reaction. The edges literally dry out and die because the plant is desperately trying to conserve water.
This diagnostic matrix right here is basically your ultimate cheat sheet. It totally proves how one single symptom, say wilting or yellowing leaves, can stem from wildly different environmental causes. Look at that wilting row. Actually think about it. A plant will wilt if it's underwatered, sure, we all know that, but it'll also wilt if you overwater it and literally drown its roots. It's the ultimate environmental paradox. You see the exact same overlap with lower leaves turning yellow. It could be insufficient light, but it could equally be way too much water. This is why you have to look at the whole environmental picture, not just one isolated symptom.
By placing these clues side by side, you can really start to train your eye. Over on the left, we see the shredding of these oak leaves. This isn't a bug chewing on them for lunch. This is purely abiotic wind damage, sometimes called tatters, which physically tears the foliage. Notice how the damage is mostly just physical tearing. But then, look over on the right. We see strawberry leaves with scattered, discolored spots featuring dead centers and little yellow halos. That scattered, highly specific spotting is the absolute hallmark of a biological fungal pathogen. Seeing them next to each other really highlights the vast difference between environmental trauma and a progressive biological infection. So, the big takeaway here is that by systematically ruling out those environmental stressors first, you are going to save your plants, you'll save your money, and you will become a true master of botanical diagnostics. Solve the environment, solve the mystery. But it does beg a pretty massive question for all of us. As extreme weather and climate shifts completely change the environments in our own backyards, how many new masterminds will our plants have to face tomorrow? Keep those detective hats close by.